Alright guys, welcome back to the channel. This is going to be a big series on the Super Sami build. I skipped a lot of steps, but today this episode is going to talk about building the front forelink for the Suzuki Samurai. Kind of update you what I got going on really quickly. Obviously I got the Chevy 350 built in there. I was able to build these really nice brackets inside. Has made it to a turbo 350 transmission and then a NP208 transfer case. One of the biggest things I did, I was able to put the engine pretty low and back. You can see the center of gravity is right over there by the bell housing here. I think it's going to handle really nicely. I took care of and I finished welding in all of the forelinks for the rear. I ended up doing a double triangulated forelink, if you can see that. We got our uppers going out inside of the Samurai frame, and then we got our lowers triangulated in the middle right underneath our transfer case. Nice solid 2x2 tubing that's a 1/4 inch thick, and then I have these adjustable brackets I was able to shove in there. I ended up going with 2-inch quarter wall DOM top and bottom. Make it as strong as possible. You know, it's a lot of power under there. I think this is a 12-bolt GM axle. We'll see how it holds up. I built this truss here out of 1/4 inch plate. I was able to just score the inside and then weld it to strengthen it. I'm going to end up building some plates here to finish this truss, but this is kind of where it's at now. You can kind of see some of the bracketry going on the inside. Yeah, so we're pretty bare boned right now. The next big step is the front axle. So this is a 10 bolt. You can tell by these cutouts in here. The GM 10 bolt. All of this came out of this Blazer that I had, 1974 Blazer. But anyways, I'm sitting at about 115-inch wheelbase, and that's due to, you know, I'm trying to get this as long as possible. You can see how short the drive shaft's going to be. It's going to be pretty short. So this is as far forward as I want to put it. And you can see it's literally hanging out the back. And the front axle is positioned here so that the pumpkin is nowhere near the motor. Anyways, let's go back to the front axle. I mocked up my drive shafts here. It's awfully long. So the beauty of the Samurai frame is that it's fairly narrow, which means the motor is like the only thing you can fit in there. You know, and the headers, you barely have any room for the headers, but they work. So this is kind of mock up where the upper links are going to be. You can see that I'm aiming to be really wide over here, to get my forelinks really wide and get as much triangulation as possible, but away from these engine mounts. I don't want to have to redo those. And then the lower mounts will be hanging at the bottom of this axle and then triangulated inwards like this, probably closer to here, and it's gonna have to hang kind of low so that there's separation. Upper link is gonna be probably around there. So the few things you need to think about is that the lower links need to be, you know, less than 10 degrees. If you get them level, that's great, but they should be no more than 10 degrees. The upper links at ride height, you want the upper links to be as level as possible. The next thing is you want to get about 40 degrees of triangulation total. So we have 15 here and 15 here, that's 30. That's not going to be enough. So hopefully the bottom is going to give you that, get you to that 40 degrees. The upper and lower link separation on the axle is 25% of your tire size. And then what I'm going to use for the truss is I got this hot rolled steel flat bar. I have a bunch of different sizes here. This is what I'm going to actually use for the truss in the front. I believe this is 5 inches. I think the total price for all this, these are expensive pieces, $10, $9 a foot. I think all of these are 50 inches each, and I have like 6 of them. This was about 200 bucks. I'm gonna score it, bend it. I'm gonna build it the same way I did here. I think this turned out really well. I had a lot of control of which angle I could put my pinion. I think that ended up being like 16 degrees, and then I could have this nice and level. So I was able to have a lot of that control. I haven't, obviously you can see I haven't built the inner piece here. So the first thing we got to do here is clean up these brackets. We got a lot of these old brackets here. We're going to knock those off. And with a lot of bit of grinding, axles are nice and clean. And ready for our brackets. Alright, now that the axle is nice and clean, the next step is to measure our pinion angle. Pinion angle is the angle of our axle here in terms of where our transfer case is. So I did a couple things here. I have plumb bobs on each side. There's this really nice tube that runs across the samurai frame. Kind of got lucky here. I threw this PVC here. And I have plumb bobs hanging off each side. And this will allow me to line up exactly where the center of the axle is. And this allows me to center my axle exactly where I need it and kind of repeatedly do that. The next thing would be to mock up an axle shaft. This will help you locate where your links can actually go and to center your axle or position your axle so it's perfectly nice and straight going into the transfer case. So this is just PVC and some clamps. Now this allows me to get a little bit of an adjustment here. This is really important to get straight because it will depict the angle of this axle and the location of it as well. So if we look at it on the side, we can see this is exactly the angle of our axle. Based on how the axle shaft goes into the transfer case. And I'm going to use this surface here as my datum. When I go back and build my truss, I need to use the same surface so we're repeatable. I think this is a nice flat surface. You'll see what I mean as I start to build the truss. But I'm going to set this here, and it's about 7 degrees. That's the angle of the pinion of this axle. So these are actually stands for leveling out a trailer or an RV. I got these at a local box store. I welded on these little flanges here to make it a pipe stand. And the whole point is that I can raise these up and down on either side, and I can level my axle perfectly. And this will help when I put my truss up and make sure my truss is nice and level, so everything is relatively plumb. All right, now that the truss is all set up, or the axle is all set up where we need to, we can start building the truss. I just have some basic cardboard I'm going to use. This is the material I'm using for the upper part of the truss. This is 1/4 inch flat bar, 1/4 inch thick, 5 inch wide. So let's build our template. Alright, so I got a preliminary little template going on here. I measure the length that I need. I made these little score marks in the board so I can get an idea of exactly where this is going to live on the axle. The plan is to have a slight bend inwards like this and be just barely maybe 1/4 inch above the pumpkin because I need this truss to be as low as possible. The next thing to do will be cut out the circles in this so I can match it up. Alright, so I think I got a notional design going on here. I made these little cutouts there, some cardboard, and this is about what it's looking at. The cool thing is, I can change the height of this by just changing this angle. But I think this is a good baseline to get me going. And then I can figure out what this angle is so that I have just the right amount of clearance underneath the pumpkin. A little bit of cleanup should do. Next thing I'm going to do is I'm going to score it at a certain distance here so I can bend it And then once it's scored, I can go ahead and weld it to make it strong. So I cut a groove in it about maybe close to 1/16 deep. I went extra on these edges here. That'll help me bend it inwards. So I'm using some magnets here in my level and a little piece of foam paper to act as my clearance between the pumpkin and the truss. I have a magnet on this end. So this is approximately how the truss is going to end up looking. What I need to know is this angle here. So with this little digital angle finder, about 131 degrees. I want to try to get these to be exact same angle. So we'll shoot for a 131. This is how I'm going to attempt to bend it. Got our first bend started. I ended up grinding this down to about 3/32 deep. It makes it a little bit easier to bend. So we obviously have a lot more bending to do, but you can kind of see what I'm trying to do here. Then each end, same amount. And this will just slip in there. So this side's just a little off. I'm gonna go ahead and just grab these wrenches, give her a bend. Looking pretty good. And the same thing on this side. Cool. So there we have it. Nice and bent up. Have just enough clearance under the pumpkin. Pretty level, as we said. And we already have this pinion at the correct angle that we set earlier, which means that we can set this to level in this direction here, the truss. We'll go ahead and just tack it right at that position so that this top of the truss is level, and then our pinion is at the correct angle that we've already established. So we're about ready to tack everything on. So all I did was, to center the axle, I just measured from this end here to this end here, and I did that same this end here to get everything nice and centered. And it looks pretty centered to me. I'm using these magnets here to help hold the truss in place so I can get this nice and level. We have our pinion angle nice and set, 7.5, and then this is close to level. See, I need to move it tilted this direction, so I'll just go ahead and grind a little bit of material off of the truss here to get that nice and level, so we're super pumped. Alright, so I went ahead and finish welded everything. Got a nice bead on the inside and the outside, and of course I finished on the inside. This wraps up the upper truss, and this is kind of the plan. Probably something like that. Gonna sit somewhere like that. Yep, and the next thing I'm gonna do is actually locate the lower links, and then eventually, once the lowers and uppers are all solidified on the truck and the axle, I'll finish up this truss build. Thanks for watching. Like and subscribe for more vids.